Myself, Dr. Ranjita Sinha, Assistant Professor in the Department of Basic Science and Humanities in Asansol Engineering College. Today going to present the introduction to simple harmonic motion. This is under subject name Physics 1 and paper code BS-PH101 module 1. Now course outcome. Now, after the completion of the course, the students will learn to describe about the basic concepts of mechanics. They can explain interference, diffraction, and polarization of light. They can state the basic principle of laser and construction of ruby laser, helium neon laser. They can interpret about electromagnetic wave equation, dielectric, and magnetic properties of material. They can understand the basics of quantum mechanics. They can discuss about the basics and applications of statistical mechanics. Now, introduction to simple harmonic motion. A motion that repeats itself in equal interval of time is called periodic motion. When a particle in periodic motion moves to and fro along the same path, the motion is called oscillatory or vibratory motion. Example is the oscillation of simple pendulum, the oscillation of a mass attached to a spring. Any oscillatory motion should be periodic, but a periodic motion may not be always oscillatory. Now the time period. The time required to complete one oscillation is time period, and frequency, the number of oscillation made per second. And the relation between frequency and time period, it is given as n equal to 1 by t. Non-equilibrium or mean position, what is this? The position at which no net force acts on an oscillatory particle. It is the equilibrium or mean position. Now the displacement of the particle. A distance of a particle at any instant from the equilibrium position, that is the displacement. And the amplitude, that is the maximum displacement on either side of the equilibrium position. Here in this figure, displacement time graph, A1 is the amplitude here. That is the maximum displacement. Displacement is along y-axis and time is along x-axis. Now here we can write F equal to minus kx. Now here a particle moves to and fro in such a way that the acceleration of the particle is always directed towards a fixed point in its path of motion and is always proportional to the displacement of the particle from a fixed point at any instant. So acceleration equal to minus kx, and we know force equal to mf. In the place of f small f, that is acceleration, we are putting minus kx, and ultimately we are getting minus mu into x. And mu here, what is this? Mu equal to mk. This is the force constant. K is the proportionality constant, small f is the acceleration of the particle, small m is the mass of the particle, x is the displacement, and capital F is the force. Now mu, that is the force constant, that is the restoring force per unit displacement. Now next we are going to discuss differential equation or equation of motion of SHM. Now if small m be the mass of the particle and x be the displacement at an instant from the mean position, then we can write m d2x by dt square equal to minus mu x. That is f in the previous slide. It is given f equal to capital F equal to minus mu x. So f equal to mf, and f small f equal to d2 by dt square, d2x by dt square. So mf equal to minus mu x. That is capital F equal to minus mu x. So same equation we are using here. Now just changing the side and slight mathematical calculation. Very easy. Now ultimately we are getting omega square equal to mu by m, and ultimately here d2x by dt square plus omega square x equal to 0. So this is the differential equation of SHM. Now next we have to solve this equation, and we have to find out the value of x. Now the solution of the equation. So we are taking the trial solution. We are trial solution as x equal to a0 e to the power pt. Now we have to find out dx dt and d2x by dt square, because ultimately in this equation we have to find out the value of d2x by dt square. So we have calculated the value of d2x by dt square, and ultimately putting all these values in the differential equation of SHM, we have this equation, and ultimately after mathematical calculation we have the value of p equal to plus minus I omega. So ultimately x equal to a0 to the power pt, so we are putting the value of p, that is plus minus I omega. So here x equal to a1 e to the power I omega t plus a2 e to the power minus I omega t. So breaking that e to the power I omega t and e to the power minus I omega t, we have this equation, we have this expression x equal to a1 plus a2 cos omega t plus I equal to a1 minus omega, a1 minus a2 sin omega t. Now what we are doing here, we are putting c1 equal to 1 plus a2 and c2 equal to I a1 minus a2. So ultimately x is a1 plus a2 equal to c, so c cos omega t plus c1 cos omega t plus c2 sin omega t. Now again what we are putting, c1 equal to a sin phi and c2 equal to a cos phi. Now if we put here in this equation, as ultimately here we are putting c1 equal to a sin phi, here we are putting a cos omega t as it is, here also c2 equal to a sin phi. Now ultimately we are getting x equal to a sin omega t plus phi. Now phi, that is the, if you phi equal to, we can find out, that is a sin phi by a cos phi, that you can do, we can divide it. So ultimately we are getting phi equal to tan inverse c1 by c2, and a equal to what, root over c1 square plus c2 square. So ultimately our solution is x equal to a sin omega t plus phi. If we put phi equal to theta plus pi by 2, then x equal to a cos omega t plus theta. Now this is the solution of the differential equation of SHM. So our solution is x equal to a sin omega t plus phi. Now you have to know what is the velocity of the particle executing SHM. Now here we have this equation. Say this is the this is the solution of the differential equation of SHM. That is x equal to a sin omega t plus delta. Say we are taking at phi here as delta. Now we are going to calculate the velocity v equal to dx by dt. So we have this one s omega cos omega t plus delta. Ultimately we have the value of sin omega t plus delta. From there we can calculate the value of cos omega t plus delta, and here it is this one root over 1 minus x square by s square, as cos omega t plus delta equal to this. So what is the expression of velocity? V equal to plus minus omega root over s square minus s square minus x square. So now come here. Now at x equal to 0, v equal to v max, that is plus minus a omega. So if we put here x equal to 0, then what is x equal to 0? Then it is root over a square, so a, so plus minus a omega. So the velocity is plus minus a omega. This is v max. At x equal to 0, v become v max. And if we put x equal to plus minus a, then we are getting this velocity equal to 0. So this is v equal to v minimum equal to 0. So for extreme position, that is x equal to plus minus a, we are getting the minimum velocity, and for equally at mean position at x equal to 0, we are getting maximum velocity. Now what is the acceleration of the particle executing SHM? Now f equal to what? dv by dt, we know. Change dv by dt is the velocity. Now we are just differentiating it again. This one v we know, so dv dt we are finding out. So we are getting this one. So ultimately putting the value of sin omega t plus delta again from this here, we are getting minus omega square x. Now we will find out the value at extreme position, what will be the acceleration, and at equilibrium position or mean position, what will be the acceleration. So we have the expression f equal to small f equal to minus omega square x. If we put x equal to 0, then the acceleration is 0. Acceleration 0, that is acceleration is minimum. And if f equal to f max, when it is, then it is a omega square. X equal to a, then f is f max. So acceleration is maximum at extreme position and acceleration is minimum, that is 0 at mean position. Now we have to know the energy of a particle executing SHM. Now what will be the energy of the particle executing SHM? we know that is x equal to this. We know the velocity, expression of velocity equal to this. Now the kinetic energy equal to what? Half mv square. So we are squaring this term. So half m omega square s square minus x square. So this is the expression of kinetic energy. Now next we are going to prove the expression of potential energy. Now, potential energy of a vibrating particle of mass m at an instant is calculated from the total amount of work done in overcoming the restoring force through a distance small x. Hence, force here, that is here we have the expression of potential energy is equal to this, and expression of potential energy is 0 to x m omega square x dx. So ultimately we are getting half m omega square x square. Now our total energy, what is our total energy? Our total energy is kinetic energy plus potential energy. So this is the kinetic energy term, this is the potential energy term. So ultimately we are getting half m omega square a square. This is constant. So the total energy remains constant. Now here, that is the graph. So potential energy C, potential energy equal to half m omega square x square. So at x equal to 0 at mean position, the potential energy is 0. So this is the curve for the potential energy. At x equal to 0, potential energy is 0. But kinetic energy, this is the kinetic energy. At x equal to 0, kinetic energy is maximum. So at x equal to 0, this is the kinetic energy curve. This is maximum. And at x equal to a plus minus a, kinetic energy is 0. So here it is 0 and it is 0. So this is the kinetic energy and potential energy graph with displacement. Now some illustrations of simple harmonic motion, motion of a simple pendulum. Now a simple pendulum of length, we are taking the length as small n. It is displaced from in mean position A. A is mean position, and it is allowed to oscillate with an angular displacement less than 4 degree. Let us at any instant t, it is at p position and ap equal to small x. So angular amplitude is theta equal to x by l. So this is the theta angle, this is equal to x by l. Now the weight mg, which is weight of the bob here, that is vertically downward, and it is resolved into following components. Force acting along the string and balances the tension T of the string. So here, so mg cos theta, it is balancing the tension T. Now next, force acting perpendicular to the string. So this is the perpendicular force, and it is force acting on the bob of the pendulum towards the mean position. So this is the force mg sin theta, and it brings back the pendulum to its initial position. Now F, this is the force. This is the force acting on the bob of the pendulum towards the mean position, and F equal to minus mg sin theta. Now if theta equal to small, then sin theta equal to theta. So F equal to minus mg theta. So F by m equal to minus g theta. And here, as x equal to L theta, we can find out d2x by dt square equal to L d2 theta by dt square. So we have equation 1 and this is equation 2. So comparing equation 1 and equation 2, we can write L d2 theta by dt square equal to minus g theta. So d2 theta by dt square equal to minus g by L into theta. Ultimately, d2 theta by dt square equal to minus omega square into theta, where omega equal to root over g by L. So the time period of oscillation equal to 2 pi root over L by g. So the simple harmonic motion, a simple pendulum executes SHM with time period equal to 2 pi root over L by g. Now another example, that is oscillation of liquid in a U-tube. In a U-tube containing a liquid, if the pressure is applied on the liquid column in warm arm of the tube, then if it is released, the liquid column will begin to oscillate in a simple harmonic manner. So this is the U-tube. Alpha is the cross-sectional area of the arms of the U-tube, and the liquid in one limb is depressed by x. So it is initial position it was, now it is depressed by x due to the applied force capital F. The liquid in other arm will rise by x. So this is the rise. This is the rise of the height of the liquid column. The difference in the two levels between the two arms is 2x. So here it is x, here it is x. So it is the difference is 2x. Due to the weight of 2x height of liquid column, the liquid columns of the two limbs will tend to come to the same level. Hence, the force responsible for the motion of the liquid column is F equal to what? Minus 2x alpha rho g. So this is this is area, this is like length. So this is 2x alpha. It is acting as volume. So volume into density, rho is the density here of the liquid. So here m into g. So like this. So here this is density, this is volume. So this is acting as mass and g. So mg, F equal to minus mg here. The mass of the liquid is what? If L is the height of the total liquid column in U tube, then the mass of the liquid is length into cross section into density. So L alpha rho. So ultimately we are writing L alpha rho, that is the mass. Then d2x by dt square, this is acceleration. So mf, then it is equal to force, that is minus 2x alpha rho g. So if we calculate just simply, then we are getting omega square equal to root over 2g by L. So d2x by dt square plus omega square x equal to 0. This is the equation of SHM. Now the time period t equal to 2 pi root over L by 2g. So here what I hear, the equation is d2x by dt square plus omega square x equal to 0. Omega square x equal to 0. So this is the equation of SHM, and omega square equal to root over 2g by L. Omega square equal to root over 2g by L. So this is the equation, well-known equation of SHM, that is d2x by dt square plus omega square x equal to 0. Now the value of omega square equal to root over g by L, and having time period t equal to 2 pi root over L by 2g. Oscillation in LC circuit. Next, consider an electrical circuit involving an inductor of L henries and a capacitor of C farads. When the capacitor is charged externally or the inductor is influenced with the help of a magnet, then there will be current through the circuit which varies with time. Voltage across the inductor, that is V equal to L into di by dt. This is the figure, this is the inductor, this is the capacitance, this is the key, and this is the cell. Now here the voltage across the inductor is L di by dt, and the voltage across the capacitor is Q by C. Now we know V equal to Q by C and I equal to dQ by dt. So ultimately I can write C into dV by dt. Now from Kirchhoff's law we can write L di by dt plus Q by C equal to 0. Now L d2I by dt square plus I by C equal to 0. So we are differentiating it, and we are getting L d2I by dt square plus I by C equal to 0, and d2I by dt square plus I by LC equal to 0, omega equal to root over 1 by LC. So here T equal to 2 pi root over LC. So here we are getting again the differential equation of SHM, that is d2I by dt square plus I by LC equal to 0, and here omega square I, that is omega equal to root over 1 by LC. So electrical LC circuit executes SHM. So this is another example of SHM. Now up to this was the introduction of SHM. Thank you all. ভুল লিখেছি একটা জায়গায়।